Design patterns are instrumental in making software design more flexible and easier to maintain, by providing well-defined ways to solve common software architecture challenges. Choose patterns based on the specific problems and requirements of your project for the best results. In this book you can learn about common design patterns grouped by categories. Bot 1. Creational patterns singleton. Description. Ensures only one instance of a class exists and provides a global point of access to it. Guidelines. Make the constructor private to prevent external instantiation. Provide a static method that returns the instance. Use lazy initialization if the object is resource-intensive, or use eager initialization for simplicity. Ensure thread safety if needed, especially in a multi-threaded environment, for example, using synchronized blocks in Java or the lock keyword in C#. Factory method. Description. Defines an interface for creating an object, but lets subclasses alter the type of objects created. Define a method in the base class that returns a new object instance. Subclasses override this method to specify the exact object to be created, which adds flexibility to object creation. Description. Separates the construction of a complex object from its representation, allowing the same construction process to create different representations. Guidelines. Create a builder class with methods for configuring the object step by step. Use a build method that assembles and returns the final object. This pattern is particularly useful for objects with many optional parameters or configurations. Prototype. Description. Creates new objects by copying an existing instance. Guidelines. Implement a clone or copy method that duplicates the object state. Ensure deep or shallow copying as needed to handle references and nested objects appropriately. Useful when object creation is expensive or complicated. Abstract factory. Description. Provides an interface for creating families of related or dependent objects without specifying their concrete classes. Guidelines. Define an abstract factory interface with methods for creating each type of product. Implement concrete factory classes for each product family, encapsulating the creation logic. Structural patterns. Adapter. Description. Converts one interface into another that a client expects, allowing incompatible interfaces to work together. Guidelines. Create an adapter class that implements the client's interface and translates calls to the incompatible interface. Useful for integrating legacy code with new systems or for working with third-party libraries. Decorator. Description. Adds behavior to an object dynamically without altering its structure. Useful for extending functionality in a flexible and reusable way. Guidelines. Define a common interface for the components. Implement concrete components and decorator classes that wrap these components to extend their behavior. Chain multiple decorators to add various features dynamically. Facade. Description. Provides a simplified interface to a complex subsystem, making it easier to interact with. Guidelines. Create a facade class that wraps the subsystem components and provides high-level methods for common tasks. Useful for reducing the complexity of API usage and hiding implementation details from the client. Composite. Description. Composes objects into tree-like structures to represent part-whole hierarchies, allowing clients to treat individual objects and composites uniformly. Guidelines. Define a common interface for all objects in the hierarchy, both leaves and composites. Implement composite classes that store child components and provide methods for adding, removing, or iterating through them. Proxy. Description. Controls access to an object, adding a layer of abstraction to manage its interaction. Use a proxy class that implements the same interface as the real object and holds a reference to it. Proxies can handle additional tasks like lazy initialization, access control, or logging. Behavioral patterns. Observer. Description. Establishes a dependency between objects such that when one object changes state, all its dependents are notified. Guidelines. Define a subject class that maintains a list of observers and provides methods to add, remove, and notify them. Implement the observer interface in classes that need to be notified of changes. Strategy. Description. Defines a family of algorithms, encapsulates each one, and makes them interchangeable to let clients vary the algorithm independently. Guidelines. Define a common interface for all strategies. Implement different strategies in separate classes and pass them to the client object, which uses the selected strategy. Command. Description. Encapsulates a request as an object, allowing parameterization and queuing of requests. Guidelines. Create a command interface with an execute method. Implement concrete command classes for each operation and an invoker class to call commands. State. Description. Allows an object to change its behavior when its state changes, encapsulating state-specific behavior in separate classes. Guidelines. Define a state interface and implement different states as classes with the behavior changes. The context object delegates state-dependent behavior to the current state object. Mediator. Description: reduces the complexity of communication between multiple objects by centralizing the interaction logic. Guidelines: define a mediator interface and implement it to manage communication between components. Components interact only through the mediator, simplifying dependencies.